Alright, so chapter 5 is largely on triangles. The second section we kind of go off and talk about polygons, which are just general shapes, but everything else will be on triangles. So the first thing you'll need to look at is classify triangles. And so you're sorry about that kind of was weird. You're going to use two words, one of them dealing with sides and one of them dealing with angles. So there's no like rule that says like the word with describing the sides has to come first or the angles, but alright, so we have something called a scalene triangle. No sides are congruent. Okay, and then we have something called an isosceles triangle, where two sides are congruent, and then we have an equilateral where all sides are congruent. Okay, then we have words to describe the angles. So we have an acute triangle. All angles are acute, less than 90 degrees. We have a right triangle, which means it has one right angle, or 90-degree angle. We have an obtuse triangle, which has one obtuse angle, or more than 90 degrees. And we have equiangular. All angles are congruent. Okay, so your first couple problems will just be pictures of a triangle, and then you're supposed to say it's a isosceles acute triangle, or it's a scalene obtuse triangle, or it's an equilateral equiangular, like one word from each of the two categories. Okay, so I will tell you this, that if all the sides are the same, then all the angles are the same, and vice versa. So if you know all the angles are the same, you know all the sides are the same. If you know all the sides are the same, all the angles are the same. Equilateral and equiangular go together. They don't go with any of the other words. Okay, so so if you had a triangle like this, this would be a scalene right triangle, because none of the sides are labeled congruent and there is a right angle. Okay, if you had that one, this would be an isosceles acute triangle, because 2 of the sides are congruent, and all those are less than 90. Okay, so for the most part, you'll be able to visually tell if something's bigger than 90 or less than 90. You know, it's not going to be 91 degrees, so you can't visually tell on the ones the triangles that are just drawn. Okay. All right, then there will be a couple problems where they give you some coordinates. And ask to classify the triangle. So be really kind of accurate about how you draw your graph out on ones like this. So -1, 2, 0, 0, and 2, 3, 4, 5, 6, and 3. Okay. So, couple things. Sides and angles. So first, this little side over here. Let me label these. So like A, B, and C. So AB is obviously not the same as the others, but AC and BC, like maybe they look similar. I don't know. So if you made a triangle and did Pythagorean theorem, so this would be, I should have drew the A somewhere else. That's a 1, and that's a 7. So 1 squared plus 7 squared is 50. And I don't need to even go any farther than that, because I really just want to compare. You know, if I wanted to know the actual length, then I would do the square root of 50. But I don't really care if it's an actual length. 6 squared plus 3 squared, 36 plus 9 is 45, and they're different. One's the square root of 45, one's the square root of 50. It's 57.1, 45 is 6.8, 6.7. I don't care the actual number, I just want to know, are they the same or are they different? So all the sides are different, so I'm going to have a scalene triangle, and then, gosh, that angle down there kind of looks like it's 90 degrees. But I don't want to just say, well, it looks like it. I need to know, is it? So if it's 90 degrees, so if angle B is 90 degrees, then AB has to be perpendicular to BC. So how would I know that? Well, kind of going back a chapter, perpendicular lines have negative reciprocal slope. So I do need to do a little triangle over here, and that's down 2 and over 1, so down 2 over 1. And then BC, I already did I have a 6 and a 3, so just remember, so this would equal -2. That the y part goes on top, and the x part goes on the bottom. And when I reduce it, I do have negative reciprocal slopes, so this is a scalene right triangle. Okay, so you're going to probably, on all of them, need to, unless there's a flat edge, you're going to probably need to do this little triangle thing like I did in the red and the blue, either for slope or for determining are they the same length or not. So it's not probably a terrible idea to just do that at the beginning. Obviously, if the side is flat, either vertical or horizontal, you don't need to do that because you know how long it is, and if it's flat, it has 0 slope. If it's Vertical, it has no slope. It's undefined, but it'll be obvious if it's perpendicular or not, because the other one would have to be horizontal or vertical also. Okay. All right. Then the other thing that we kind of introduce is called, let me write the actual theorem number down just for reference. Theorem 5.1. It's called the triangle sum theorem. So it says it in some form, but angles of a triangle add up to 180 degrees. This is kind of one of the major theorems in geometry, because from this point forward, if we have triangles and we know stuff about angles, we know we can add them up to 180. It's going to be helpful in certain problems. Okay. Just looking at something to see if it comes up, but I don't think it does. Okay. So two kind of problems to do with triangle sum. So a simple one would just be like that. So, okay, well, we're going to add these, and then we're going to subtract from 180. So, simple, hopefully. And then the other one could be something like this. So, all three of them add up to 180. X plus 3x plus 2 plus 90 equals 180. So then it's, solve the equation. X and 3x is 4x. 2 and 90 is 92. So make sure that you go back and answer the question. So on some of these, it might just say solve for x. Some of them it might say, or it will say, find the measure of each acute angle. Well, that one is 22. Now, you could do one of two things here. You could plug in 22 for x over here, or I know that one, this is 90, and this one is 22, so if I wanted to, I could just add them up and subtract from 180, or you could plug the 22 in for x, whichever you like better. There's no must be this way, must be that way. So there is something to point out here, that problem, if you wanted to just do this plus this equals 90, get 4x plus 2 equals 90. Subtract 2. And we're in that same spot. Might save a little bit of work, or at least the numbers are a little bit smaller. So, you know, the real difference is I'm doing 180 minus 92 versus 90 minus 2. Probably easier. It's listed in your book as what's called a corollary. And it's similar to the theorem 5.1, corollary to triangle sum. So basically, and it kind of, maybe you thought this on the last problem, maybe you didn't, but if you have a right angle 90 degrees, so if all of them add up to 180 and I take away the 90 or the right angle, then I have 90 degrees left over. You can know that angle A plus angle B equals 90. You can change how the triangle looks, but if you have a right angle, the other two are going to be 90. So in that previous to do just the 90. Okay, so as long as you're showing your work, no problems. Some of you need to write more stuff down than you are, but okay, then one last one. Theorem 5.2 is what's called the exterior angle theorem. So if you like extend it out the triangle, one of the sides, angle 1 would be an exterior angle just because it's on the outside, but it also shares, like, you know, a side of the triangle kind of thing, where BC is part of the triangle and that's also part of angle 1. Can't just be any random angle like outside of a triangle. It's got to be like right next to it. So what that says, this theorem says, is angle 1 equals angle A plus angle B. Okay, so whatever that exterior angle is, it's going to equal, they call them remote interior angles. I think they use that word. Nope, it says, they used to call them remote. In this book it says the two non-adjacent interior angles. So, not angle 2. The other one's across from the triangle. Okay? So, if we had similar picture, hopefully I have enough room to do the problem here. Alright. So first, okay, I got an angle on the outside, I got the other two, so x plus 70 equals 2x minus 5. So, gotta do some algebra here. Okay, so again, make sure that you answer the question. So if it said solve for x, then you're good. Even if it said find angle A, you're good. But if it said find angle, what if it said find angle ACB? So what if it said find like that angle where I put the number 1? Well, then you would need to do 180 plus 75 is 155. Or excuse me, goodness gracious. I would need to do 70 plus 75 is 145, and then do 180 minus 145. And so we'd have 35 degrees. If it said find the exterior angle, you would need to plug 75 in next to the 2 and find that one. So 2 times 75 is 150 minus 5 is 145. So just make sure on these problems that you, after you solve for x, that you go back and answer the question. Okay, so you'll have some classifying, some solve for x or find the missing angle, some with just numbers, some with x's. Okay, and then the very last problem is a figure. It's like 2 triangles kind of connected together, and it's going to ask you to just find all the different angles. So remember, you're going to have to pull back some information from prior chapters on this one, as well as all the angles add up to 180 and stuff like that. You can certainly use the exterior angles equals the 2 non-adjacent angles. You can use those as well, but vertical angles are congruent. Linear pairs is supplementary or adds up to 180. You'll need to use, or you could use those as well as the 2 theorems that we talked about and the corollary that we talked about today. Okay? All right, so the big idea of this chapter, or this section in my opinion, is all 3 angles add up to 180. That's a big one that will keep coming up. Not to say that the other ones, or the exterior angle theorem, won't come up, but the all 3 add up to 180 is for sure a more prevalent theorem that will come up quite a bit. All right. Have a great rest of your day, guys. We'll see you tomorrow.